So today we're going to be talking about projectiles. So the horizontal motion is always going to be constant. We're going to neglect air drag and other forces like that. And vertical motion will be influenced by gravity. So we can call the horizontal motion Vx and the vertical motion Vy. A dropped object hits the ground at the same time as an object launched horizontally. I'm going to draw a diagram that illustrates this idea better. So as you can see, the V in the Y direction is accelerating, meaning it's getting bigger, and it's doing it at the same rate for each object. One was just dropped and one was thrown horizontally. So they are accelerating downwards at 9.81 meters per second squared due to gravity. And of course, the velocity in the x direction is constant, meaning v1x will equal v2x. Impact velocity, or v2. Here's a simple diagram of v2. We can see that it has an angle associated with it. And here's a close-up of what that v2 vector really looks like. You can see that it's made of two components, v2y and v2x. And v2 can be found using Pythagorean theorem because a right triangle is formed with the two components. But we can't forget that velocity is a vector, meaning it needs a direction associated with it. That angle can be found using trigonometry and must be found relative to the horizontal, not the vertical. So an example of a completed final velocity answer would include the calculated magnitude of the velocity along with its impact angle, relative to the horizontal. Now let's move on to an angled launch. So an angled launch will have an angled initial velocity v1, as you can see in the diagram there. If we take a closer look at this v1, we can find it very similar to the other v2 we just looked at. It has an x component and a y component, and they can be both calculated using trigonometry. So for this example, we're going to start with a person, and this person will be on a cliff, and this person decides that they want to run and jump off the cliff. So this means that the person will have an initial velocity and an angle at which he leaves the cliff at. And this person will fall and eventually will hit the ground, but thankfully he falls on a bunch of pillows so he does not hurt himself. And so when he hits the ground, he will have an impact velocity. We can call that v2, and it will have an angle relative to the horizontal. And he will also have a range, which is delta d in the x direction, and he will fall on a certain height, which is delta d in the y direction, which would just be the height of the cliff. And of course, there will be a total flight time for when the person leaves the cliff and when they softly impact the pillows at the bottom. And all of these values can be calculated thanks to the fabulous 5 kinematics equations of motion. Some awesome applications of projectiles include cliff jumping, gun shooting, and ball throwing. I would encourage everyone to go out and use their knowledge of projectiles in everyday life because physics is fun.